Okay, so good evening and welcome to this week's BossConstructor development livestream. Today I'm going to do two things. First of all, we are going to implement the winning module of this week's voting round, which is the maneuvering thruster, which is a 1x1 tile, very low efficiency, low thrust propulsion system, which is designed to make ships like maneuverable in directions which you usually don't need them, and just give you some more options for propulsion. Hello, Jay Grimes. Thanks for joining the stream. Okay. And since this is probably going to be a very fast implementation, because it largely bases on mechanics and assets which are already in the game, in the second part of this stream today we are going to improve the laser module which we have in the game. So as you know, the laser module is, well, technically far from being laser, because it's more like a very fast projectile, and yeah, we're going to try to make it a real laser, and we're going to try to make it look much better. Okay, so that's something to look forward to today. And also I'm going to get some pizza later on, which is great. Okay, so let's start by making the maneuvering thruster. First of all, we're going to make the graphics. Then we're going to add it to the game. And finally we're going to test it. So yeah, this is probably going to be very, very fast, because it is going to be just like a miniature version of the basic thruster which is already in the game. Okay, so let's start Inkscape, and let's start on the graphics. Yeah, so let's start with the, where is it? Thruster. Okay. A little bit of confusion, because this is sort of an old module and it doesn't follow the naming convention of the other stuff. Okay, so if you haven't watched the streams so far, the graphics are done in a multi-stage process, so to speak. And the first step is to make a height map. So basically, the more bright the color tones are in this graphic, the more elevated it will be in the upcoming steps. So, cluster. It's going to be 1x1 module, so I've restricted the document size a bit. Guess I can make the background a bit more dark, so that you can see it better. Having a bit troubles with the key bindings today for some reason. Okay. Good. So yeah, this isn't going to be like magic. This is just going to be a smaller version of the previous module. So let's just make this step a bit faster so that we can go to the other steps, like the what is it? Like the laser module. Okay, so let's remove some of this stuff. And let's mix this stuff. Make it 3 bottom thruster in a plus shape. Yeah, but the plus shape would be confusing because it only propels you in the in this direction. I mean, technically, we can make this into multiple parts. I mean, yeah, sure. Let's try how it looks. Okay. Okay. Let me just elaborate on my thought process. So I want to make the graphics in a way that it is very clear what the module does. So it should be clear that it will propel you like in this direction. And I also want to keep the general level of like visual clutter to be sort of consistent, which I guess is already sort of fulfilled in this case. Okay, but I sort of like this suggestion to make it multiple parts. So let's try this. So I guess what we could do is something like this. Oops. Making it propel in all 4 directions is actually sort of problematic because you can only bind 1 or 2 keys to a module, and it would not be clear in which direction it would propel you. And I'm afraid this is not so easy to do. So I'm sorry, but it will only go in 1 direction because that would just change too much of the game mechanics to be reasonable, I think. I'm very sorry. But I do like your suggestion of making giving this like multiple thruster outputs like this. I think that will look pretty good. What am I doing here? Oh, what the hell? Springs or hydraulic looking thing. Hydraulic looking thing. It is sort of supposed to look like a thruster. Hydraulic looking thing. Can you elaborate a bit on what you mean? Okay, let's make it like this. Okay. Okay, so basically I'm adding multiple layers, which will all be different height levels later on. Okay, like a scissor lift or car jack. Let me just Google this. Okay. So lift, check. Okay. Give a second. Vielen Dank. Ja.
Ich habe auch noch so Gemüseauflauf unten und noch mehr Pizza.
Das ist schon,
okay.
ja, ist genug. Okay, so I just got a pizza, so I have to take a short break soon, but before, yeah, I mean, this is going to be like a thruster because it is related to the other thrusting things. Okay. Okay. So let me just complete this step. Need to get the darker tone out here. Yes. Okay. 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 And now I need to duplicate this part. There may be some layering issues here which we have to resolve. I guess this part is, yeah, I guess this part is not good. So let's remove it. Okay, I'm actually fairly positive about this one. So yeah, but as usual it's sort of a trial and error process. Okay, so let's export it. Okay, and now let's turn it into a really nice graphic. Okay, here we go. Okay, so somewhat like this. So I'm very sorry that I have to tend a bit to my pizza now. But this is pretty much... Yeah, actually I like the multiple thruster output because it does look more interesting than the other modules, and we already have two modules which are based on the basic thruster design. Yeah, that was actually a GIMP script which I've written for this purpose. Yeah, I call it make shadows, and basically it does a number of grouping and how do you call it? I mean, it's basically directional blur and subtraction combined in a way that it gives these shadow-like effects. I mean, I can show you a bit how it looks. So basically a shadow to the right would look like this, or shadow to the left would look like this, or shadow upward like this. And yeah, I really like it. It took me a while to figure out how to make it, you know, look not horrible, but I'm sort of satisfied with the result so far. Okay, so next I'm going to open the what is it called? The basic thruster module, just to get an idea of the brightness levels which I have to use. Okay, this is sort of good already. I guess I'll make these output, I don't know what it's called, output parts a bit darker to be in line with the other stuff. So I'm going to make a new layer. I'm going to give it a transparency layer. I'm going to fill it black. And then I'm just going to paint the parts which I want to be darker in white. Okay, so now we can change the look by adjusting the opacity of this layer. Yeah, it already sort of looks like how we want it to. Let me adjust the general tone curve a bit. I don't know why it always opens this dialog on another screen. I wanted to make it a bit more contrasty. Okay, and finally I'm going to add a little bit of detail by, where is it? By overlaying a general space texture, which is pretty much just like a plating detail or something. Set the layer mode to multiply. Now we can just add a little bit of fake detail. I mean, it's hardly visible in the game later on actually, but well, whatever. Okay, good. So next we need to generate and export 3 different layers. The first layer, so first of all let's save it before it has a chance to crash. The first layer is going to be the diffuse layer, which is what we already, like the base layer which we can see, which is just called like this. The second thing is going to be the color mask. And the color mask is basically the part of the module which will light up when, or which will change color when you assign one to it. And unfortunately, this is sort of messed up. Yeah, I think we might have to, do this one manually. This is one part which does not work as well automatically as I would like. Okay. So basically So the color mask determines how the color which the player selects for a module influences how it looks. And in this case it's going to be like a stripe, which takes on the color of the module. Yeah. I mean, to be frank, this module is going to be pretty tiny later on, so there isn't really too much point to put like a huge amount of effort into it. I mean, I'm pretty satisfied with how it looks, don't get me wrong. Let's make this layer mask a bit fuzzy, or maybe not as fuzzy. Back 2. Okay, so this is the mask. And finally we need to generate a normal map. So for the normal map we're going to make a duplicate of our original layer and apply a normal map plugin. This is a plugin which I have not written, it is like a publicly available thing. And we need to scale it a bit to, let me think a bit. Yeah, this should be fine. In case you don't know, a normal map basically determines how the light reacts to your module. So if you write a custom shader like I've done for BossConstructor, this will be used to determine if a part of a module lights up when the light comes from a certain direction or not. So in this case, the greenish ones mean that this part of the module is oriented to the top. So if light comes from the top, this part will light up, this part will be dark, and so on. Okay. Let's export it as normal. And let's eat a piece of pizza. And let's see how it looks in the game. So we're going to begin with our basic thruster module. And since the functionality is largely the same, I guess we can make a copy of it and go from there. Maneuvering thruster, okay. Okay. Next I need to make a short description of the module. It's a cheap but inefficient way to propel your ship. Okay. And just add it to the German version as well. Okay, so text is done, graphics are done. Now let's put it here. So first of all, the size is going to be 1 by 1. Cost multiplier is okay. Block size -2 is okay. So basically block size determines how many squares in front of the module will be unavailable for other modules. Now drive thrust is, well, as you can guess, the amount of propulsion which we get. What would be a nice number? I mean, it has to be less efficient. Okay, so dividing this by 3 should give, like, if you would just scale down the efficiency. If you divide by 4, okay, that looks good. I guess 60 looks like a good value for this. I mean, but of course, balancing is totally random in a way. Okay, energy generation. I guess we can just divide this by 3. Okay. And actually, it would be more elegant to just subclass the basic thruster, but I'm not sure. Yeah, this might run into problems later on. Yeah, so I guess in this case coupling is like not pretty, but it's less prone to error. Let's put it like that. Okay, I guess keep prop. Okay. So okay. Okay, we can remove all of this stuff, I think. Yeah, we can. I'm wondering what this is. This is the code which is used to automatically guess the keys which are bound to a module. And since this part at least is identical to the basic thruster, we can share the same method. Okay. So I mean, I guess we have to test it to find out like what parts we need to adapt furthermore. Destroying the module should be okay. I guess we have to make like the track of the module less dominant than the basic thruster, but we can just try it out. And also we need to change the position of the flame behind the module, and I guess make this flame a bit less big. Maybe like half as big, I guess. Okay, so finally we're actually pretty much done. Now we need to add it to the list of modules. And finally we need to add it to the research tree. I'm not sure yet where it would fit actually. I guess we can add it here. Yeah, I guess this would look nice. Okay. Okay. Okay, I'm actually pretty confident that it should work now, so let's give it a compile and let's see how it works. Yeah, correct. It's just copy paste error over here. Okay, so. Okay, so let's start by having a look if it shows up here. And it does. Nice. So we have propulsion rocket, thruster rocket, and maneuvering thruster over here. The text seems to be okay as well. The cost is really high actually. Why is it so expensive? Okay, it needs to be less expensive. Hit points are okay. Rate is okay. Energy used is okay. Drive thrust is also okay. Good, so we only need to change the cost. I'm a bit confused. I mean, we just copied the code from the basic thruster. Why is it so strange? Well, whatever. Let's just set it to 25, I guess. Okay. So let's see how it works. So I'll just take one of our ships. And let's remove our main engines. Or maybe not. Let's just remove our backward facing ones. Let's add a lot of maneuvering thrusters. Very nice. Okay. I see some errors already. Okay, I don't know if it's visible on stream, but it looks like the whole module is getting colored in the masking color, which is not correct. Let's just check what we did here. The color mask was this. What happened here? Oh, okay, so accidentally we just copied the same graphics. Okay, yeah, that explains it. So, mask, and that should be it. Nice. So that will be fixed the next time we compile this stuff. But for now, let's check if the functionality is working. So I'm going to put some of these in every part. Okay.
Begin mission.
Okay, so our forward-facing thrusters work like before. And the backward-facing ones also work. They are much weaker, of course, like they should be. Nice. And due to the way we have placed everything, we should also be able to strafe, which is nice. Yeah. Okay, so basically I think the gameplay justification of these basic thrusters is that they allow you to implement like movement in directions which isn't like the main functionality of your ship, but which still allows you to like dodge an incoming asteroid or something else. Okay, so let me compile the 2 changes which I made. And eat another piece of pizza. Hello, David. Good evening. Unfortunately, you already missed most of the, like half of what we do today, because the maneuvering thruster is almost done. There were just some bugs which we needed to fix. But I think it should be largely functional now. Okay, yeah, as you can see now the color mask is actually correct. The normal maps also seem to be correct. So as you can see, as the ship rotates, different parts of the module light up, which is how it should be. And okay, so some improvements which we can make. So we have like one big exhaust thingy, which doesn't really fit if we have these tiny, these 2 small ones. So we can improve that. Yeah, and other than that, I pretty much like it. So okay. Let's improve this part. Okay, so basically we're just going to make 2 different flame thingies. And, well, let's just guesstimate where they should be. Maybe 1.0.3, I guess. Maybe, maybe not. Let's test. But don't worry, you can still see how we improve the laser module of BossConstructor. So there's still plenty of things to do today.
Begin mission.
Okay, let's zoom in a bit. Okay, so we have 2 flames now coming out of it, which is nice, but I think they need to be a bit closer to each other. Okay. Okay, but we can fix that, of course. So let's make it 2, 3, whatever. And let's make it a bit shorter. Okay. So you want pistons? Yeah, actually they are on the module voting list, so people can vote for them. And I will obviously implement them when they are voted for. But let me be clear, pistons are not easy. Every part of the code which requires me to, break up ship parts and manage the physics system are usually not very friendly, not very nice. But I agree in the sense that pistons would really make like a big improvement, and I'm pretty certain that I will implement them at some point. Yeah, sooner or later. I guess I should make the smoke effect a little less strong. Yeah. What's going to be in the voting list? Okay, so I can show you. You just go to the BossConstructor page on Steam. You go to Community Hub. You go to Discussions. You go to Wishlist and Suggestions over here. And you go to... you can either post your idea in a new thread here, or you can just join the module idea collection and vote thread. And here you can see all the modules which are in the current pool. So these are the modules which have already been voted and included in the game. And this is the pool which is currently in the game, so which will be shown in the survey when you start the game. And these are modules which will be, in the pool next week. And modules which have received a lot of votes will, come back in the pool later on. I think the piston should be here somewhere. Let me search for it. Yeah, it is. It is actually here in the high priority pool. So the piston idea will come back. Yeah. Sooner or later. What was I doing? Okay, yeah, I wanted to decrease the length of the smoke thingy. Okay, I guess this is here, and I need to make it disappear faster, I guess. Yeah. Let me just look in the constructor what we need. Particle texture, size, lifetime. Texture, size, lifetime, okay. So let's just divide it by 4. That should make it shorter. Let's see.
Mission.
Yeah, I think it works, right? What does it? Yeah, it does. Like, these side ones are disappearing much faster. Maybe I can make the effect a bit more obvious. Limiter Vx. Okay, yeah, okay, I can. I can make it like output this stuff not as strong as the basic thruster. So let's see. Okay, let's give it a try. Yeah, very nice. So this is sort of what I had in mind. So it's a much weaker effect compared to the basic thruster, but that is pretty much what it should be like because it is weaker. Okay, so as a final test, let me add this to like a extractor test. Okay, I don't have it here, I guess, for some reason. Okay, I don't have it here. I just want to test how it would behave in like really big ship, like, well, I mean, this is the factory, so it shouldn't really be moved anyway, so, well, I mean, moving factories would be pretty cool actually, but, well, whatever. Okay, so, I'm not too sure where I should add these actually. I mean, like, what would make sense from a design perspective. Well, let's test it. Oof. Okay. I mean, they are really weak, but they do provide some propulsion. I sort of like the idea of having a factory that slowly moves towards you. Maybe I'll do that. Oh, actually, I really like the idea. I mean, it's really slow, but oh wait, I want to do that actually. Actually, I really like it. So let's do it like this. Let's just remove the spotlights, or at least one of the spotlights, and add a maneuvering thruster on each side, like this. Oh, and we can even put one here. Okay. Oh god, players will hate me when they have a factory moving towards them, but I mean, it's very slow, so it's mostly for cosmetic purposes. Okay. Test it. Okay. It is really slow, yeah. I mean, it is sort of okay at turning because it has a lot of modules there. And it cannot move backwards. Well, but I like it. So, let me just see, does it make sense to have, yeah, I guess I'm going to add 2 backward facing ones, so that it can at least break a little bit. Okay, so let's add this new factory to the game. Source, ship, library, autofag, medium, ship. Okay, nice. So, now the factories should be moving a bit. I guess I should also add the maneuvering thrusters to the mining and freighter ships, just because it makes like more sense from a general perspective. Okay, so let's add it to the patch notes list. Okay, good. Okay, so maneuvering thruster is sort of done. Check. And now, since we have some time left, let's try to improve the laser module. Yeah, so first of all, let's revisit how the laser module looks at the moment. And then let's try to figure out how we can turn it into a real laser. So first I should elaborate, there are several reasons why I would like to do this. Do I not have a laser testing ship? Well. Well, let's create one. Okay, so we basically have two laser weapons in a way, because the sword weapon is just a small scale variant of the laser. Okay. Let me just fix one small thing, because I just realized that the energy sword still has the old style. Normal map. Just a second. Okay, this will take just a second. I just need to duplicate this guy and create a new normal map. Yeah, much finer and much more detailed than the previous one. Okay, just export it. And done. Okay, good. Okay, so how does it look like at the moment? Well, like this. Maybe I'm not going to change it for the sword, because there it looks sort of cool, but as you can see the laser really has a very spray effect, which doesn't look like laser at all, and which also consumes a lot of power to calculate, actually. I should note, by the way, that there is a railgun in the game, which does have a straight line effect already. However, it is going to have a little bit of a different function gameplay-wise, because the laser is just going to hit the target which is straight ahead, like it does now, while the railgun module basically shoots through things and will hit harder if you have larger objects. Okay. So how do we do it? So basically, we have to change the graphics. We have to change the fire and damage code. And we have to make new effects. So this is going to be our agenda for the remainder of this stream. Okay, so let's close GIMP. Oh, by the way, I should actually announce on Twitter that I'm streaming. Well, I guess it's a bit late now, but okay, whatever. I don't know if Twitter works at all. Anyway, okay. So, let's go to the laser module. Let's close all the other stuff. And let's figure out what it is doing. So first of all, currently it only implements one function, which is the fire weapon function, and which principally just spawns a laser shot at really, really high frequency. So the minimum delay is 0.015, which is, I think, 60 frames per second. It's not? Okay. Then it's actually a bug, whatever. But it shoots at a really high frequency and has relatively low damage. Okay. Make the color of the laser changeable? Yeah, sure. Okay. Sure. Okay. Good. So basically we have to replace this function which we have used previously, and instead, oh, I guess we can keep the sound for now, and create a new graphics function. Okay, so we have to do this. And we have to do this. Okay. Good. Okay, so I'm currently thinking of which module we could use to steal code for the render top. I guess we can use the... Let's use the code for the thruster which we have used previously. Yeah, it should work basically. Yeah, we will probably have to make a new texture for the new laser beam effect, because it's going to look really awkward like this. And we need to change the range of the module. Okay, so currently the range is 130 times 0.6 to 78, okay. And I would like to leave it like that, but at a much higher, you know, printed speed. Okay, so going to make the speed 800 and make this like a 0.1 second lifetime. I mean, these will obviously not really be used anymore because the laser is now going to hit instantly, so basically the speed is going to be infinite. But it is still used at other places like the tooltip for the module or like basic ship statistic calculations, so I guess we can leave it like that. Yeah, but of course we can calculate the range, so actually is it not calculated already? Well, whatever. So basically range is what is it actually? Weapon range, okay. Okay, we already have weapon range as a variable, so we do not need to make it ourselves. And we're going to start to make the worst laser effect ever. Good, very nice. Weapon range. Weapon range, okay. Okay. This is probably going to look really bad for now. But we have to start somewhere. Oh, and also it is always on at the moment, so even if we are not firing, which is a bug of course. In fact, it is even on when we're in the editor. Okay, so this is not quite what we want, but where is our testing ship?
Begin mission.
I mean, honestly, this doesn't look too bad. Like the direction is wrong because we took the code from the thruster module, which shoots behind, instead of the weapon modules which shoot in front. Oh, I sort of like it actually. Okay, so let's work with this for the moment. Let's change the direction for the effect, and let's make it so that it only is visible when we shoot. So how can we do it? Okay, so let's make a time last fired, and time last fired is going to be set to the world time whenever we fire, and here we can just check if the world time is identical to the time last fired. Okay. Okay, so we only render this effect if the time last fired equals world time. Should be good, should be good. And we can also make this effect flicker a bit. So let's set the transparency to 60% plus 40% random. Okay, let's give it a try. I mean, obviously I'm going to make the laser effect much prettier and, you know, more powerful looking later on. But for now we need like a basic graphic effect to see the range of the laser module and see how it works in general. And it immediately crashes. Why does it crash? Well, I guess because world is not always defined. So. Oh, is it defined at all actually here? Or do I need to use another world object? I guess I do. Okay. Okay, so it has to be a bit more complicated. So only if ship_part is not null, and only if ship_part world is not null, and do it like this. Okay, yeah, actually here it also uses ship_part world, so I was using the wrong world module. Okay, let's add a comment. Okay, while it is compiling, we can have a look at the, how is it called? I don't know what it's called properly in the box to the engine scope, but what we need next, now that the effect should be working, I actually sort of like how it looks. It consumes like a huge amount of power, okay. Actually, yeah, okay. I sort of don't like the sound effect, to be honest. So I'll put it on my to-do list to change the effect at some point. Okay. But nevertheless, what we need next is the actual code which will damage the enemy. And oh, it's actually going to be harder than I thought. Because we have to sort of distinguish between this kind of objects which we can hit, but okay, whatever. So good. Okay. So now we have these beams, which are technically speaking just lines, and we need to check using the physics engine if there is an intersection between these lines and objects in the world. And when we've done that, we need to figure out at which intersection is closest to our module. Okay, so let's find them intersections. So also let me make the flickering a bit weaker because it was a bit annoying. Or maybe even weaker still. Okay, so we already have a piece of code which uses this functionality of the physics engine to find intersections. And this is used at the cosmic wind thingy. So if you don't know, the cosmic wind is the wind which pushes asteroids, ships and so on in a certain direction. And in order to do this, I calculate different lines at different levels and see if stuff intersects with it. Okay, so how do I do it? Raycast line, re-execute, okay. Word raycast, okay. So raycast is CW. CW is probably the current cosmic wind, okay. Okay, so this is a reference to our own object, okay. And P1 and P2 are two vectors which determine where the stuff is. Fair enough, and then the physics engine should call this function, report fixture. Okay, it should work. Yes, David, actually I want them to, only hit the first object which they see in a way, because there is already the railgun which shoots through things. So laser should be first target only. Which will not be too easy actually, because I've heard that it is sort of difficult to get this to work. I mean, in order to sort and figure out which intersections are closest and so on. But we'll figure it out somehow. Okay, so in order to get this raycast function to work, first of all we need to implement this raycast callback. Then we need to copy this report fixture code, which is pretty much an implementation of this function. And this is actually already sort of a nice base function which we can work with. So for now, we can just print out all the stuff which is intersecting, which is a good start, I guess. So, and now we need to call the casting, which is done here, which is actually sort of neat. Actually, this might be easier than I thought. We'll see. Shepard word. Get a body. Okay, so basically I should elaborate a bit on what this is doing. So when I call this raycast function on the physical world, this is a box2d function, then it will cast a line. This should be this. These should be 2 points. And for all the intersections within this line, this function will be called, report fixture. A fixture in box2d is pretty much a part of a physical body which has certain physical properties. So typically these are like box shapes in BossConstructor, or circle shapes like in the asteroids, for example. And so whenever we have an intersection, this function will be called. we can use getBody to get the corresponding body for this fixture. And then I've created a lookup table which will allow me to figure out what object in my in my world corresponds to this object in the physics world. Oh, by the way, I should actually update the title. Let's see if it works. I don't know, for some reason I cannot change the title of the Twitch stream, which is a bit annoying. Well, whatever. Okay, so what we need to do now is to define the line which the laser will be crossing. And for that I can steal code from the railgun, I think. Yes, like this. Done. So P1 is a new vector from relative to this module and this position. Let's say we start at -3 and we go until -3 plus weapon range. Okay. I think from a logic perspective, this should be correct. Well, doesn't mean that it will compile and whatever, but let's see. Let me just turn on the light. Okay, it did compile, which is nice. Yeah, now let's see if it works. So let me open the log file. So this will show the console output of the game.
Begin mission.
And now let's just see if we do hit stuff. Okay. It is already intersecting with some stuff, which I guess is the module itself. Which is obviously not what we want, but let's see. What if we hit that asteroid? Okay, that doesn't really seem to do anything. Okay. So, if you turn around, does it work then? Okay, it works if you turn around, so I'm guessing that the direction is just wrong. Okay, so apparently the direction is completely wrong, which is why it is intersecting with our own... Oh, okay, I'm an idiot. If it is negative, then I need to make this negative as well. Okay, yeah. That explains that. Okay. Okay.
Begin mission.
Okay, that looks much better. So now it is no longer colliding with anything when we hit nothing. And now it is hitting asteroids. And Let's see how many we get. So yeah, we get intersections with different types of asteroids, which is nice. Okay. Let's just test another ship, like here. Okay, it works too. Nice. Okay. Okay, so the raycasting and the object detection seems to be working. Now we need to do two things. So first of all, what we now need is to sort intersections by distance. And then we need to do, we need to do actual damage to stuff. And we need to do effects, but one thing at a time. This might be trickier than I thought. Or maybe not. Maybe not, actually. Maybe not. Okay, so what is happening now? So if we have a situation like we had previously when we hit multiple asteroids at the same time, then this function will be called multiple times. However, as far as I know, there is no way to tell which is the first module which we got. So it will probably be called multiple times. And what we need to do, I guess, is to make a list of all the stuff we hit. So let's call it stuff we hit, which is going to be a new linked list of world items. And before we do this raycasting function, we will clear this list, and afterwards we need to find the closest stuff. Okay, so okay. So what we do here now is, if we have found an object which intersects, we will add it to the stuff we hit function. Okay. Okay, so next, once this is done, this list should now be filled. And now we need to traverse through this list and find the stuff which is closest. Okay. Closest hit. Closest hit distance. Something like this. And now we're just going to go through all the elements in this list. Stuff we hit. And we're going to check if distance of this world item and our ship part is smaller than the closest hit distance. Then we're going to set the closest hit distance to this. And we're going to set our closest hit to WIP. Okay. Okay. Okay, good. I'm sort of assuming this already works. I'm going to make like a debug output so that we can double check it if it doesn't. And next, we need to add the damage code. And the damage code we can pretty much steal from the, what is it? From our contact handler. So basically the contact handler is where all the damage is processed. Like physics damage, like collisions and shots and whatever. Yeah. It's a little bit unfortunate because we sort of have to implement this for every type of object. Huh? This is really not so pretty actually. Yeah, it's not really so pretty, but I guess we have to do it. Okay. Okay. Since this might come up later on in the development, I'm going to make a universal function. Damage stuff at position. And this function will take an item and it will take the damage and it will take the position, which is closest to the point at which damage is taken. This last part is actually only important if we hit ship parts, because it does make a difference at which point of the ship part the damage is applied. Okay, so damage stuff at position, our closest hit. We should check, by the way, if yeah, stuff we hit. Yeah, we should only do this stuff, of course, if we actually have a hit. So if we do not have a hit, we do not need to do it. So closest hit. And now our damage. How is it called? Weapon shot damage. Okay. And finally the position. And the position is pretty much the position of our ship part. Technically this is not correct, because the position of our ship part is obviously not the point of the intersection, but it should be, you know, the closest point in most cases. Maybe we need to fix this later on, I'm not sure. Yeah, maybe this is not correct. Maybe we need to do something about it later on. Okay. Good. Okay. For now, I'm just going to implement one specific case, which is the asteroid, so that we can test it. I think I prefer to make like many different intermediate stages which can be tested individually, so that, you know, get a nice sense of progression on the one hand, but also have like manageable amounts of changes. Okay, so how is it done for the asteroid? Okay, pretty much just asteroid damage. Okay, good. Damage. Done. Just to get an additional output, let's just output the damage if we are in this function. Okay. Let's see if it compiles and let's see if it works. Well, it does not work because I misspelled it. By the way, this cast as is one of the nicer constructs of MJava. It basically checks if this object is instance of asteroid, and if it is instance of asteroid, it casts it as an object of type asteroid, which is called asteroid. So it's really neat. Okay, many different errors. Oops, first of all, run e5 f because it is a float. Second, distance is not defined for this stuff. Okay, so instead we need to do, well, for what is defined then? Distance, dist. Okay. For some reason I have a function distance and a function dist. I don't even want to know actually. I don't even want to know. Okay. Dist. Nice. Can't be applied to given types. Okay. For some reason I had ship part over here. Okay. Let's try again. Okay, so we corrected one instance, but we failed to correct the other one. Whatever. I'm actually really curious if it works now. I mean, there is a fair chance that it works. So, come here, asteroid. Okay, it does not work. Why does it not work? Let's check. Oops. Oh. Hello? Oh, it does work. Oh, it does work. It only looks like it doesn't work because there's no explosion. Okay. Okay. Oh, I guess, by the way... okay. So we need an explosion when it is something, because it just looks weird when there is none. And second, I just got the idea that actually this waycasting function gives me a point. So maybe this is the point where the stuff intersects. If it is, that would be really convenient. So let's try it. So let's make a class reported fixture, And we're going to collect these reported fixtures, which contain a world item point and let's call it collision point. Or hit point. It is a bit ambiguous, but yeah. Okay, so reported fixture, new reported fixture. FWIP is WIP, and rf.point is point. No, hit point. Okay. Now we need to change it here. Stuff we hit. Well, okay, this is a reported fixture now. And instead of WIP, we use rf.wip. Distance is WIP. And closest hit is now a reported fixture. Okay. The WIP. And closest hit point. Okay, I'm really curious if this works. If it does, that would be really neat, because it saves us a lot of trouble to figure out the actual position. Okay, so now I want to add a little explosion at that point. Since I'm pretty lazy, I'm going to take the explosion from the Actually, where do the explosions come from? I wonder. It does not seem to be in the abstract shot function. Is it here? Abstract shot. A shot is destroyed. Okay, it is done manually over here. Fair enough. I'm not quite sure why this is done here. I mean, and a new particle explosion, okay. Okay, I'm actually going to refactor this a bit. I mean, actually the explosion should be a function of the shot. Yeah, so let me add shot explode. And we can give it a position, which is here, I guess. And we're just going to make the function here. Explode. Okay. Let's just change it around a bit. Okay, world would be here. Vec2 would be our position. If damage is 0, let me do it like this. What? It sort of doesn't make sense. I'm not quite sure what this is supposed to do. Well, if we don't know, then we can just... yeah. Wait a second. Yeah. Okay, yeah. I guess I can just comment this out for a moment. This, shot px, world, shot. Okay, so, by the way, if you're new to programming, or if you're just learning to program, if you have code like this, where you have like the same object in front of every argument, it is a pretty good sign that you need to refactor it. So if everything here is relating to the shot object, then usually it should be part of the shot class. This is a pretty good rule to go by, actually. So let's do it. Okay, very nice. So now we have an explode function, which we can use not only where it was previously used for the contact handler, but also in our new laser class. So we can now just... Oh, I'm an idiot, I cannot. I'm sorry. This is not entirely correct what I just said, because I mean, it is correct, but it doesn't really work in this case because we no longer use this shot object. Yeah. Well, I mean, let's not make it too complicated, I guess. Yeah, let's not make it too complicated. We can just copy these two functions and whatever. Okay, so let's add a new position. Damage position. Okay, should work. And I guess we can do the particle explosion later on if we really want one. Okay, so for now I just want to progress and improve this stuff. But actually I'm fairly happy with the progress so far, because I wasn't quite sure if it would be so simple. I'm sort of already doubting my decision to make this static, because it would probably lead to problems later on, so let's not do it. At this point at least. I mean, if we need it static, we can still do it later on. Where is it? Nope, nope, yeah.
Begin mission.
Now I'm curious, will it work? Wow. It does work, very nice. Okay, as you can see, it sort of passes through, which is not what we wanted. Which is totally not what we wanted. But... And, I mean, it is a bit confusing that the laser seems to pass through. I don't quite get it. Why is this code not working? What does it... What does it... Strange. Huh? But does it spawn explosion there but doesn't do damage? This is really strange. I mean, it looks like the second asteroid wasn't really damaged. It's actually a really strange bug. Actually, a really strange bug. Strange. Very strange. Very strange. Okay, so I guess at this point we can make a slight improvement by using the actual hit point rather than atom point. Well, this function doesn't exist yet. Okay, that should work. What else did I want to change? Okay, so first of all we have to make sure that it works at all. Yeah, and actually we can also begin adding new stuff to take damage from our laser module. So what do we have? Pirate bases, mines, interceptors, shield plates, ship parts. Okay. Yeah, I guess ship part is going to be the hard part. Okay, so let's begin by doing the not so hard part. Okay, so pirate bases, pretty simple. Mines, pretty simple. Mines are just being destroyed. Interceptors, pretty simple. Yeah, interceptors are just being destroyed. Shield plates, also pretty simple. Okay, okay. So now we've added more objects which can take damage from our laser. Plus we have changed the way the distance function works. So maybe this fixes the bug. I'm not quite sure yet. In the case it does not, we can do some debugging, I guess. Close it. It was a really strange bug, by the way. Okay, you want to make the laser color changeable. Yeah, I guess we can do this right now. In a way, it already should be. Wait a second. Let me test it. It already should be changeable, but we can test. We can test. I mean, we need to test it anyway now, so let's do it. Also, we still need to add effects, which are not done yet. Yeah, that's not what I wanted. Okay, so let's make this one red and this one blue, for example. Or green. Why not green? And let's add some more in different colors, just for the taste of it.
Begin mission.
Yeah, they do change color. I guess I can make the effect a little bit stronger. Yeah, I guess I can do so. Yeah, good. Okay, so... Okay, so far so good. It is still not limited by the... You know, the effect still seems to pass through everything. Let's see what happens here. Okay, so the ship part, which is here, should not take damage. But there's still an explosion. Okay, interesting. Okay, but now there's no explosion at the asteroid behind it, which is nice. Well, there still is. Actually, there still is. Well, but it's not taking damage. This is so strange. This is so strange. I mean, the function where the explosion is spawned is the same function where the damage is applied. So it should not be possible to, you know, just have the effect but no damage. It's so strange. We test it again on this guy. Ah, okay, wait a second. Wait a second. What does our log file say? Nothing? Did I forget to put it here? Yeah, I did. Okay, maybe I'm doing this function incorrectly. Wait a second. I'm returning -1. Wait a sec, let me check in the documentation. Where is it? World querying, managing wakecasts, wakecast callback. Okay. If you return 1, it will continue to give you additional hit results. If you return 0, it will immediately stop. Okay. So why am I returning -1? Well, I'm guessing -1 is incorrect then. Okay, so let's test +1. Well, if the error is here, it is also in the cosmic wind module probably, because I also here have -1. Well, whatever. Actually, there's still a slight bug because the laser module, like the laser shot, is now colliding off of other shots, which is not intended. Well. Okay, so next. How does it look like if we make the width flicker a bit? Actually, let's test it. Okay, whatever. Okay, this might have been the error. So now this problem might be gone. We still have the problem that the effect is too far, so that it passes through everything. And this is what we're going to fix next. Okay, so we have last time fired. Now we're going to make last shot distance. We're going to use last shot distance down here. For our effect. Okay. And by default we're going to set last shot distance to weapon range, okay. And if we have hit something, we're going to set it to the distance between our module and the stuff which we hit. Sounds reasonable actually, yeah. Okay, so now we'll set it to the distance between get point wait a second, track 2 this module position, this module position X, this module position Y, and then hit point X and hit point Y. Okay, so it's tested. So we should have fixed the distance of the laser module shot effect, plus we might have fixed the fact that it is... What did I do? We might have fixed the effect that it is passing through stuff, which it should not.
Begin mission.
And now it is working, nice. What the hell? Did it even compile? Okay, so the distance is going way up when we hit something. So at least it is doing something. It's not doing the right thing, but it is doing something.